This is Christopher Sernaque hosting episode 13 of season 3 of the Current Topics in Science podcast. This podcast will address breaking scientific news in light of the origins debate and host interviews with scientists. This podcast is available on the following platforms: iTunes, Stitcher, Google Podcast, Spotify, and iHeartRadio. Video recordings of the podcast will be uploaded to YouTube. Enjoy the podcast. Today on Current Topics in Science, we have the honor of hosting Dr. Stephen Meyer. Dr. Meyer has a Bachelor of Science degree in Physics and Earth Science with a minor in Philosophy and Math from Whitworth College, where he graduated cum laude. He has a Master of Philosophy degree in the History and the Philosophy of Science from the University of Cambridge, England, with an emphasis in physics, molecular biology, and evolutionary theory. He also has his PhD in the History and Philosophy of Science, likewise from the University of Cambridge, which he earned for the thesis of Clues and Causes, a methodological interpretation of origin of life research, which analyzed scientific and methodological issues in origin of life biology. Dr. Meyer worked as an oil industry geophysicist at the Atlantic Richfield Company, was an associate professor of philosophy at Whitworth College, and was a university professor at Palm Beach Atlantic University, where he taught the conceptual foundations of science. Dr. Meyer has numerous scholarships, honors, and awards, such as the award for Best Essay in the Journal of Interdisciplinary Studies. Dr. Meyer has authored over 50 articles in scientific or academic journals, over 50 magazine and opinion editorial articles, and he's been featured on popular media outlets such as ABC, CBS, NBC, Fox, and Good Morning America. Furthermore, Dr. Meyer has authored best-selling books and monographs such as Signature in the Cell, Darwin's Doubt, and the latest, The Return of the God Hypothesis, 3 scientific discoveries that reveal the mind behind the universe. Finally, Dr. Meyer is the director of the Discovery Institute Center for Science and Culture. Dr. Meyer's accomplishments and resources can be found in the show notes for this podcast lecture. In this interview, we're going to look at the practicality of the idea of intelligent design, how the ideas in Dr. Meyer's books have fared across time, and review some of the evolutionary challenges to the theory of intelligent design. Now, without further ado, good afternoon, Dr. Meyer. How was your day, and how are you doing?
Well, I'm having a great day, especially after that overly generous introduction, and I'm really glad to be with you on the podcast. Thanks for inviting me on.
Dr. Meyer, it's an absolute pleasure and honor to have you here. Before we get to this week's current topic, I wanted to talk about your latest work, namely The Return of the God Hypothesis. I haven't yet finished reading the book, but I was working my way through the first section and beyond. I have your other 2 awesome books, Signature in the Cell, DNA and the Evidence for Intelligent Design, Darwin's Doubt, The Explosive Origin of Animal Life and the Case for Intelligent Design, and, last but not least, The Return of the God Hypothesis, 3 scientific discoveries that reveal the mind behind the universe. So I highly recommend all of them, but I do have some questions about the third one. So there's 3 questions for this first question. Dr. Meyer, how would you recommend that readers tackle the new book? So are there certain chapters that they should pay the closest attention to? What were some interesting experiences or thoughts that you had while you were writing the book? And what questions should or might the reader be asking themselves as they page through the book?
Right. Well, let me begin just by briefly describing what the book is attempting to accomplish, and then I'll try to remember each of those 3 questions in sequence. The book is building on the prior work I did in Signature in the Cell and Darwin's Doubt, in which I made a case for the intelligent design of life based on the discovery of information, especially information in a digital form in the DNA molecule and some of the other large biomacromolecules in living cells And in those books, I argued that information in our experience, in our uniform and repeated experience, is a product of mind. Whether we're looking at software code, and of course, Richard Dawkins has even acknowledged that DNA is like a machine code. He said the machine code of the genes is uncannily computer-like. This week, he tweeted really a wonderful tweet. He said he was knocked sideways by the intricate and miniaturized data processing capability inside cells, and he linked to an animation by an Australian medical group that actually shows the process of DNA replication, which should knock anyone sideways. It's amazing, the sophistication of the digital information processing that's going on inside our cells at this very moment. I mean, all of us depend on this technology. So the first two books were about the problem of explaining the origin of that information and information technology inside cells. And I argued that our uniform and repeated experience shows that information, especially when we find it in a digital form, whether we're talking about a computer program or a hieroglyphic inscription or a paragraph in a book or information in a radio signal, always arises from an intelligent source. So the discovery of such information at the foundation of life, inside even the simplest living cells, is evidence of the activity of a designing mind or a designing intelligence in the history and origin of life. What I've done in the new book is expand that case to address a question that I didn't address directly in the first two books, and that is, well, what kind of mind are we talking about? What is the identity of that mind? What kind of a designer are we? What kind of designer is responsible for life in the universe? And what can our science tell us about that question? And so in the new book, I expanded, in a sense, the range of data under consideration and didn't looked beyond just the evidence that we have of design in biology, but also looked at the evidence we have for design in physics and in cosmology. And just as there is evidence for intelligent design in the history and origin of life, I argue that there's evidence of design from the very beginning of the universe as well, in something that physicists call the fine-tuning of the basic physical parameters, the laws and constants of physics, the initial conditions of matter and energy at the beginning of the universe. And then thirdly, there is also evidence that the universe had a beginning. And I argue that those two discoveries, in conjunction with what we know about the design of life based on its informational properties, suggest a designing intelligence that has the following attributes: a designing intelligence who is transcendent and capable of structuring the whole of the universe in its fine-tuning and bringing the universe itself into existence from something that was not material, and not in space and time, not matter and energy, not space and time, something that transcends those domains of our physical universe, because it's the universe itself that comes into existence. And secondly, we must have the designing intelligence responsible for life must also be capable of structuring or fine-tuning the universe from the beginning to allow for the possibility of life. And that means that designing intelligence could not be an entity within the cosmos. It couldn't be some intelligent space alien, because clearly no alien being or no immanent intelligence within the cosmos could be responsible for the origin and fine-tuning of the universe itself. After all, any being within the cosmos depends for its very existence, even its evolutionary origin, on the prior fine-tuning of the laws and constants of physics and the initial conditions of the universe. So when you bring the physics and the cosmology in, I think you have a very powerful indicator of a transcendent designing intelligence who is then also active in the creation long after the beginning, as we see all that information arising in our biosphere long afterwards. So by looking at those three pieces of evidence, I think we have evidence not just of a designing intelligence of some unspecified kind, but a designing intelligence with attributes that have long been associated with the notion of God. And I call that the return of the God hypothesis. So that's the argument in short of the new book. It's a synthetic argument, or kind of a cumulative case, drawing these different threads of evidence together and arguing that theism provides the best overall explanation of that evidence when compared with other competing metaphysical systems of thought or worldviews. Deism might explain the evidence we have at the beginning, but it doesn't explain evidence of design that arises long after the beginning, because a deistic creator doesn't do anything by definition after the beginning. Materialism explains none of these classes of evidence, and the space alien designer idea might explain the origin of the information in the first cell on Earth, though I think that's problematic on its own terms, but it certainly doesn't explain the evidence we have for the origin of the universe itself, or the fine-tuning of the universe from the beginning. So I kind of play almost a game of philosophical survivor, keep kicking different worldviews off the island until the only adequate explanation remains, and that is the God hypothesis, a theistic God who is transcendent, intelligent, therefore personal, and active in the creation.
Thank you very much for that summary, Dr. Meyer, of the new book. And so, like, when a reader is looking to tackle the book, are there certain chapters that you'd say, well, this one, like, if you want to make sure you get the whole book, make sure you get this chapter? Or certain chapters that you'd recommend maybe readers hone in on as they're going through the book?
Well, one of the things that I do, and this sounds, it's a heavy book in some ways, because it's tackling this great ultimate question and bringing in evidence from multiple disciplines within science. But one of the things that I do that I hope will help the reader is to tell a story. And the story of the book is a rise, fall, rise plot structure, if you will. It begins with the story of the role of theistic thinking, Judeo-Christian thinking, scientists during the period of the scientific revolution from roughly 1500 to 1750, and even before that time, who are drawing on concepts from the Hebrew Bible as they're rediscovering the doctrine of creation, rediscovering indicators of ideas like the laws of nature. And so science arises in a very distinctly Judeo-Christian milieu. This is happening in the late Catholic Middle Ages. It's happening during the period of the Protestant Reformation. It's happening among scientists who are religiously devout, who are drawing on ideas from the Hebrew Bible and the inspiration they're getting to reaffirm a Christian understanding of creation. And so I tell the story of how these Judeo-Christian ideas gave rise to modern science. One key idea is the idea of intelligibility. The scientists during this period became convinced that nature had a hidden order that they could understand because it had been made by a rational intellect, namely the mind of God, and that same rational intellect who made nature also made our minds in his image so that we would be capable of understanding the order, the lawful order, the design, and the rationality that had been built into nature. During this period of time, many of the leading scientists, in particular Robert Boyle, Johannes Kepler, and Sir Isaac Newton, are also making design arguments. They're seeing evidence of design in nature, and they're pointing, as Newton did, to the role of an intelligent and powerful being in setting up nature with this beautiful and mathematically describable order. We lose that perspective, though, by the end of the 19th century, by and large. Figures like Darwin, Marx, Freud, Huxley, Haeckel in Germany, these are the great scientific materialists, and they attempt to explain the origin of all things by reference to strictly undirected, unguided natural processes. And go further than that, even when Darwin explains where we came from. Marx had a utopian vision of where we were going in the future, and Freud addressed the human condition and what to do about human sense of guilt. These are the big questions that religion, Judeo-Christian religion, had always addressed, but now they're being addressed from a strictly materialistic and allegedly scientific point of view. And so by the end of the 19th century, we lose this kind of theistic orientation or philosophy of science that had given rise to science in the first place. And what the book does is tell the story of three great discoveries that are bringing that theistic perspective back, or at least should be. And those discoveries are, again, that the universe had a beginning, that the universe has been finely tuned from the beginning or soon thereafter to make life possible. And then thirdly, that at the foundation of life, there is information in indeed a digital form that's reminiscent of our own high-tech digital technology. And that evidence arises long after the beginning of the universe. So by looking at those three key pieces of evidence and how they were discovered, the book not only makes an argument, it tells a story. So we have a kind of Christianity gives rise to modern science. That perspective is lost in the 19th century, but it's coming back. And then I tell the story of these three discoveries. So I think for readers, more than zeroing in on just a single chapter, you can kind of get a little bit of the overview of where the book's going in the prologue in the first chapter. But the main thing is to follow the storyline. And the storyline is, just as I've said, near the end of the book, I respond to objections to the argument for the return of the God hypothesis. I respond to key objections from biologists, from physicists, and from people working in cosmology, something called quantum cosmology, and show that in either the objections fail to explain the origin of, for example, the information needed to build life or the fine-tuning necessary to life, or they subtly end up presupposing the existence of God for some other reason. So there's a kind of twist at the end showing that even the strongest objections to what's called the cosmological argument actually presuppose the need for a transcendent intelligence. They subtly presuppose such a thing and therefore don't refute the cosmological argument for God's existence. So, but many readers can profitably read the book through the first 14 chapters and say, yeah, the technical objections may be a bit too tough. So then they can skip ahead and read the concluding chapter 2021 if it gets a little heavy sledding in my responding to very technical objections from biologists, physicists, and cosmologists. But keep the story arc in mind. That's the key thing. There's an interesting and fascinating story that I think we can all kind of resonate with because we all sense this is going on. There's a returning openness to intelligent design, to evidence of God in nature. And that was an idea we once had that we lost for a time.
So that's amazing. So the book not only has this amazing foundation laid out in the first 14 chapters, but it even goes a step further, answering different interesting objections that are coming up to the ideas presented in the book. Now, I do have another question. It's interesting, though, you said that there's a central story arc to the book. I'm wondering, is there a story behind the story of the book? Like, my brother and I actually were working on a book, and, we have our interesting fair share of many sleepless nights going over the manuscript. I mean, do you have any, interesting stories or thoughts that kind of came into your head as you were writing Return of the God Hypothesis?
Well, I have a tremendous sense of completion, finally getting this over the finish line. And I tell a little bit of my own story in the book as well. In the first chapter in particular, I tell the story of my attending a conference in, I'm embarrassed to say how long ago it was, 1985. I was a young scientist, just a couple years out of college. I was doing digital signal processing of seismic data for an oil company. Conference came to Dallas, where I was working, that was investigating the big questions at the intersection between science and philosophy: the origin of the universe, the fine-tuning of the universe, the origin of life, and the origin and nature of human consciousness. And these topics were being addressed by scientists and philosophers on two sides of a great philosophical divide: the divide between the theists, those scientists who believed in God, and the scientific materialists, the agnostics and atheists who thought that matter and energy were the things from which everything else came, as opposed to a personal intelligence. And it was an absolutely fascinating conference. And at the conference, in the very first session on the origin of the universe, a famous Jewish agnostic named Alan Sandage rose to the podium and surprised everyone by sitting on the panel with the theists. And during his presentation on the origin and fine-tuning of the universe, he explained how this evidence, as well as others, had led him to consider the possibility of God's existence, and at the conference announced that he had had a religious conversion and was no longer an agnostic, was no longer an atheist, or a materialist rather, but he was now a theist and had come to believe in God because of, not in spite of, evidence from his own field. And so that was, quite an extraordinary talk to witness. And in the next session on the origin of the first life, another scientist named Dean Kenyon, who had been a leading chemical evolutionary theorist, announced that he had repudiated his own theory of the chemical evolutionary origin of life. That's the idea of the first life coming out of the prebiotic soup as a result of undirected chemical processes. And he announced that he was had come to accept that there was some evidence of design in the digital code that was present in the DNA, and actually said that it was time for the philosophers to reopen the question of natural theology. Could we know the reality of God from looking at nature? And this was also a mind-blowing kind of event where you have a leading scientist announcing an intellectual conversion to theism as a result of scientific data. So I got fascinated with both these two questions, ended up meeting another one of the scientists who was at the conference on the panel on the origin of life. And over the next year, had many long conversations with him. Within a year, I was off to Cambridge and decided I wanted to work on the origin of life question. And so in other words, I did a deep dive initially on the question of the evidence of design in biology. Was there compelling evidence or not for intelligent design in biology? Ended up in 2009 writing Signature in the Cell. But then after I wrote that book and Darwin's Doubt, I had many questions about, well, what do you think about the identity of the designer? And I began to think again about those early cosmological arguments to which I'd been exposed, and thought, if those are solid, then we can say a lot more about the identity of the designer, especially I thought. And so I've been really thinking about this question for 36 years, something like that. And had even right after the conference began to work on a little documentary film script for a small company. That didn't work out. I ended up going to grad school, but I've been thinking about this for a long time. So for me, there is a story behind the story in writing the book. It's kind of almost my life story. And so I've been thinking about this so much and for such a long time.
That is amazing. It sounds like you had to do a lot of soul searching and all those scientists in order to make the leap from either agnosticism or atheism now to belief in theism or God. They had to maybe ask a lot of tough questions. So are there any questions that maybe a reader you feel might be asking themselves, or maybe you think maybe they should be asking themselves as they're going through Return of the God hypothesis?
Well, the book raises, I think, many of the important questions that people will want to be thinking about. The first, I think, is the first thing everyone wants to know is, well, on what basis could we even think about science pointing to God? What kinds of discoveries might lead us to such a radical conclusion? Most of science, and this is something I readily acknowledge, concerns ongoing processes of nature, how one part of nature affects another, or what nature ordinarily does without any apparent guidance or assistance from outside. And so a big part of science is essentially neutral with respect to these big questions. The formula for salt is the same whether you're a theist or a materialist or a pantheist or whatever. But there are classes of questions that arise in science that are concerned with that have larger worldview implications. And typically those questions are about either human nature, the nature of the human mind, for example, or they're about the origin of the universe and life and different life forms. So I've been very interested for a long time in the questions that are at the intersection of science and philosophy, and those typically are questions of origins. And so just for readers who might be thinking, well, how could science say anything at all about the God question? That's where I encourage them to focus their interest and to recognize that those questions of ultimate origin are questions that might be answered by a strictly unguided materialistic process, in which case the worldview of materialism or naturalism might be completely adequate to explain what we see in nature. Or those questions might be better answered by reference to some sort of pre-existing intelligence, in which case something like theism or deism might provide a better overall worldview explanation for the natural world. I attended a conference in the year 2000 at Baylor University called The Nature of Nature. And it brought together a number of Nobel laureates and leading philosophers and scientists. And the point of the conference was to discuss whether nature is better understood as a self-existent, self-contained, self-organizing system, or whether to explain nature, we need to we need to think about something outside nature. Does nature explain itself, or is it better explained by some entity external to itself? Was the focal question of the conference. And that's, I think, a good way to think about what I address in the book is what is the nature of nature? Is nature pointing perhaps to something beyond itself to explain its origin? And I argue that indeed it is, that the best evidence that we have from physics, biology, astronomy, cosmology, et cetera, is that there is a designing mind that's responsible for what we see in nature, and that the designing mind must even exist independently of nature to account for everything we see in nature as a whole.
Dr. Meyer, thank you so much for those thought-provoking questions. And I'm sure that many readers are going to enjoy the new book, The Return of the God Hypothesis. But since this is current topics in science, we're going to quickly look at this week's current topic. So this week's current topic is an article by Adrian Wolfson. I think that's how they pronounce the name. So they're the author of the book, Life Without Genes. And Wolfson's article is a review of the book, Evolution Gone Wrong: The Curious Reasons Why Our Bodies Work, or Don't, which features some of the latest evolutionary arguments and points against the intelligent design theory. Wolfson says that human beings have fallible bodies and that a series of evolutionary trade-offs means that even healthy bodies operate at the edge of acceptable performance, predictably prone to fail. In this article, Wolfson makes the case that the human jaw, the human eye, and human bipedalism are all examples of unintelligent design. And he also says that human beings are poorly designed on an anatomical level, saying, "One requires no better evidence of our design's lack of metaphysical oversight than the absurd configuration of our esophagus and trachea, so near each other as to invite trouble. A benign creator would surely have designed a respiratory system in a way that did not leave us in perpetual fear of choking. But once again, this apparently bizarre arrangement results both from our evolutionary origins. The lungs began as an offshoot of the digestive system, and from the requirement from a descendant larynx. This clunky anatomical fault may give us a fright every time a hot dog takes a wrong turn at the intersection, as Mr. Berridez writes, but it also facilitated the origin of human speech." So, Dr. Meyer, what do you think of this article? Are human beings just examples of evolution gone wrong?
Well, I, for one, do not live in fear of perpetual choking. I think that the portion of that you just read sounds a bit overwrought. But stepping back from that, there have been these God wouldn't have done it that way arguments going all the way back to Darwin. There have been arguments, for example, about the vertebrate eye being poorly designed. But when you look at these arguments, what they typically fail to take into account are what engineers call optimization concerns. And that what you have is with many of these designs that are questioned as being suboptimal, is that what you have is actually a constrained optimization in which multiple design parameters are being optimized in a series of trade-offs simultaneously. So the eye that is thought to be suboptimal is also the same eye design that eagles use and have, their amazingly acute vision. So I think I'm not familiar with all the systems that this author is questioning, but there has been a general problem with these arguments for suboptimality, and that is that they tend to look at one design parameter in isolation of all others and say, that's not the best absolute way you could have done that, without taking into account that the biological system that's being examined is effectively maximizing multiple parameters simultaneously in a set of trade-offs that give the best overall design for that system, and not just looking at one parameter. So I've never been super impressed with those arguments. Stephen Jay Gould made some of the first ones. He didn't think the panda's thumb was properly designed, but it's a pretty good tool for scraping bamboo, and the pandas rely on it. So I would say, I would concede and accept that nature is not, the designs we see in nature, or rather the organisms today, are not perfectly or infallibly designed. We are all subject to death, and there is evidence of decay in nature. So there is a certain form of intelligent design theory that would suggest that everything must be perfect to be. There in the 19th century, there were many people who wrote about design who gave the impression that nature was perfect and there was nothing wrong with it. But that was more of a Neoplatonist view of intelligent design. Not all proponents of intelligent design are theists or necessarily Christians or biblical Christians, but I happen to be such a person. And I think if you conjoin the theory of intelligent design with a biblical theology of nature, you would expect to see two things. And that is, number one, you'd expect to see evidence of aboriginal design, good design in an original system, but then also evidence of decay. And you have a biblical testimony to both, that there's evidence of God's design in nature, but we also should expect to see nature in bondage to decay, is actually the biblical phrase. And even at the molecular level, we're now seeing this in viruses and bacteria. Harmful bacteria and viruses are almost as a rule a consequence of the loss of genetic information. Virulence is the technical term. We have a biologist, a microbiologist, Scott Minnick, who works on this, and he's shared that when you have a virulent strain of bacterium, you can see the places where information has been lost. And he actually has done a natural history of the plague, showing that 4 successive mutations that can now be tracked in the history of life are responsible for that incredible virulence and that killed so many people. So, from a biblical ID perspective, I would expect to see both evidence of original design and subsequent decay, and that's exactly what we do see in nature. And so I think that provides confirmation of that perspective.
Dr. Meyer, thank you so much for looking at the current topic. So Wolfson, he spent quite a lot of time in his article talking about what a designer would and would not do, as seen in statements like, a rational designer would have never included such gratuitous largesse. We're constrained and confined by our evolutionary baggage. And this statement, it brought back to mind one of your appendixes in Signature in the Cell called Some Predictions of Intelligent Design, where you listed a dozen ID-inspired predictions. So Wolfson, it seems like he's making the claim that so-called bad design in life is evidence against the intelligent design position. However, in your first book, it seems like you've already taken that into account. One of your predictions was, if an intelligent and benevolent agent designed life, then studies that putatively bad designs in life, such as the vertebrate retina and virulent bacteria, should reveal either A, reasons for designs that show a hidden functional logic, or evidence of decay of originally good designs.
I guess I did say it, right? That's a shorter way of saying my previous answer, right? And that's what with the vertebrate retina, that's exactly what's been revealed, is that there was a hidden logic that made clear why the trade-offs were made. There was a constrained optimization of multiple parameters, design parameters simultaneously, and so it's a very good overall design, even if some individual parameters are not completely optimized. And then secondly, the other case is the case where you have evidence of decay, and we do see a lot of that as well, especially at the molecular level. That's, after all, what mutations produce. I think the inversion here is, and the challenge to the evolutionary biologists is that they have inverted the relationship between good design and mutation. They want to say that mutations are the engines of innovation and creativity, and that the evidence of suboptimal design proves that there is no designer. I would say that mutations degrade original good design, and that the evidence we have of design, like functional information and irreducible complexity, are evidence of an original design, the activity of original designer, and that mutations, to which they attribute creativity, are a means by which that design is degraded. So they've attributed creativity to a degradative process, and that's, I think, what the opposite of what we see in nature. Also, a perspective like that offered by Dr. Wolfson, I presume he's a doctor of some kind, presupposes that the mutation selection mechanism has the creative power to produce these even suboptimal designs. And I would challenge that, and have challenged that in Darwin's Doubt, for example. I don't think mutation and selection has the creative power to produce even new protein folds, novel protein folds. It can slightly modify existing proteins and protein folds, but it does not seem to have the capability of producing novel protein folds, let alone new organ systems or body plans. So until there's a viable mechanism of undirected evolutionary innovation, I think it's silly to, or it's not very persuasive to argue that designs that we judge to be suboptimal are evidence of the creative power of evolution. We don't have independent evidence of that mechanism having that kind of creative power. And that's being increasingly recognized by evolutionary biologists themselves, who are saying things like, natural selection explains the survival, but not the arrival of the fittest. There was this conference in 2016 at the Royal Society in London, convened by many evolutionary biologists who now doubt the explanatory adequacy of the neo-Darwinian mechanism. So simply pointing to designs that you find to be suboptimal does not really provide positive evidence of any evolutionary mechanism capable of producing any design, optimal or otherwise.
Dr. Meyer, if you don't mind, I'm going to go a little bit off script because I want to make sure I'm kind of tracking with you. So I was thinking kind of about an analogy as I was listening to you. So say it's almost like we have cars, right? The designer, you make all the cars, right? And now you can't, like you said, there's engineering trade-offs. So you can't expect, one wheel that might work for another to work perfectly in another. But another point is that the cars, they're rusting out, and that's almost like the mutations. That's not making them better. Everything's degrading. It's more like extinction, not evolution.
Car is a good analogy there, because you might look at the car engine and say, gee, this wasn't designed. I mean, a really rational designer would have made this car capable of flying as well. And then you look at the rust on the car and you say, see, this is suboptimal. It's obviously degrading. But the rust doesn't imply that there was no design, nor does the design for motive transformation or transportation on land mean that it wasn't, nor does the lack of evidence that the car was also designed for flight mean that it wasn't designed for transportation on land. And I think the critics of the designs that we see in nature are making, in one case, unrealistic expectations of any design, since all designs require such trade-offs. And secondly, treating decay as if it were evidence of no original design, when in fact you can't really have decay of a design if there wasn't design in the first place.
Well, thank you. I'm glad that the analogy worked out. I just wanted to make sure I was tracking with you. Now, to go back to the subject of the predictions in your book, I want to take a look at the dozen ID-inspired predictions list again. Now, I've always wanted to actually hear you give maybe like a separate talk on like every single one of these and explain how you maybe went about compiling them. So, Dr. Meyer, how did each of these predictions fare? Like, the book came out in 2009, so are there any that maybe you'd take out of the list, or maybe you'd rephrase them, or are there any other new predictions that could be added to the list? So like another list of ID-inspired predictions.
Well, there would be, because we're supporting a lot of research around the world in which scientists at mainstream universities are using intelligent design not just as an explanation for data that we already have, but actually as a guide to discovery, what's called a heuristic in science, where they're saying, okay, I'm convinced that of intelligent design is the best explanation of the digital code in DNA or the irreducibly complex circuitry or molecular machines we find in cells. And so I'm going to assume that life was designed, and I'm going to now make predictions about what we ought to find in some other aspects of living systems, if in fact a designing agent was responsible for the origin of those systems. And so they're going out and looking for example, design patterns that we know from complex information systems that are designed by human engineers. So there's a scientist in Germany who's been looking for what are called overlapping genes, which is a way of encrypting information by layering codes on top of codes or messages on top of messages. That's something that can be done in cryptography, in the sending and using of codes. And he wondered if, well, that type of a design pattern might also be evident in life. That's something you wouldn't expect if life arose through undirected, unguided processes, but you might expect something like that if it were the product of a sort of genius, intelligent designer. And he has in fact found that there are overlapping genes in all 6 reading reference frames, both in the forward and reverse direction in the genome of bacterial cells. And there have been about 17 peer-reviewed papers now published on that topic. And much of that research was funded by our own institute. So that's an example of an ID-generated prediction, a discriminating prediction, one that wouldn't have been made by proponents of mutation and selection. And it's been confirmed. More generally, I think one of the most important predictions I made in the epilogue of signature in the cell, and other intelligent design proponents have made, is that the non-coding regions of the genome, the parts that were thought to be junk, would turn out to be importantly functional. And in 2009, one of the objections to the book that was posed at the time was, well, if the information in DNA is evidence of a designing intelligence, then what do we say about all of this non-coding DNA that isn't functional? And I included in an epilogue in the 2009 book a number of initial indicators that non-coding DNA would turn out to be coding. But I also listed it as a prediction that we'd get more evidence of same. And indeed we have. Within a couple of years, the ENCODE project was published. And now it's, I think, widely recognized that the majority of the non-coding DNA, upwards of 85%, does perform an important function in the cell, or many important functions. Overall, the non-coding regions are functioning much like an operating system in a computer, which are coordinating, in this case, the timing and the timing and expression of the coding files of the protein coding parts of the DNA. So there's a kind of hierarchical organization of information where you have some information controlling the timing of the expression of other information that's built into the overall genome. So the junk DNA has turned out not to be junk, just as we did predict.
Dr. Meyer, those predictions, they sound like exciting research projects. And speaking of research projects, I'm wondering how holding, you already kind of touched on this, but how does holding to the intelligent design framework impact research? There was a lecture that you gave with Dr. Douglas Axe called Intelligent Design 3.0, where you mentioned how Professor Shapiro graciously named Richard Sternberg as the first one to have the insight that the non-coding regions will be functional. Though we will have differing evolutionary philosophies, I need to acknowledge my colleague Dr. Sternberg saw this first. He saw it first because he holds to the view that life was designed by intelligence.
Clear that the quotation probably ends after he saw it first. Shapiro did not go on to say he saw it first because he holds to intelligence, but that was what he was alluding to when he said that Sternberg had a different evolutionary philosophy. Sternberg is a proponent of intelligent design. You're absolutely right. And as early as 2001, he was writing papers on the hidden function of the junk DNA. And this was something that he anticipated because of his sympathies for the design hypothesis. And I thought it was very gracious of Professor Shapiro, who is a third way evolutionary biologist. He's neither a neo-Darwinist nor a proponent of intelligent design. He's a proponent of a idea he calls natural genetic engineering. But he acknowledged in the Huffington Post, in an article after the publication of the ENCODE project, that it was Sternberg who first anticipated that these vast stretches of non-coding DNA would turn out to be, again, importantly functional for the overall for the genome in the cell overall, and that has been borne out. And so that's an example of intelligent design leading to some important discoveries, or at least anticipating those important discoveries.
Yeah, I remember when you mentioned it in that presentation. I thought that was amazing. I was like, wow. So what I took away from that was, okay, so it sounds like there's going to be lines of reasoning or pieces of evidences or patterns that an ID scientist, they might be more inclined to pick up on because they're holding to that viewpoint of intelligent design, whereas maybe somebody who doesn't hold that view, they might not see those things. So,
and let me interject just about why that would be so, because a lot of people have a hard time seeing how that could be. But we know things about how intelligent agents design things. We know the kinds of structures and features of design systems that are present in design systems. And so knowing something about how we design, for example, complex digital information technology, and knowing that the cell has information technology in it, we might anticipate that some of our known computer design patterns might be at work in the digital information processing systems within cells. This came home to me one day when I was having a conversation with a Microsoft engineer who was working with us and he wrote 10,000 lines of code to help us simulate what's called the gene expression system. And he came into my office one day and tossed a book on my table. I see it over my shelf across the way. It's called Design Patterns. And he said, I get an eerie feeling that someone figured this out before us. And I said, what do you mean? What are you talking about? He says, well, a design pattern that's a term of art in computer science for an established means of storing or processing digital information. And he said, I'm seeing all kinds of known design patterns from high-tech digital computing that are present in living cells, in the gene expression system. In the cell, he says, or in our computer, we have hierarchical filing, files within folders, folders within superfolders, et cetera. He said, you've got the same thing in the organization of the genome. You've got an error correction mechanism in your computer. It's called spell check, right? There's automated error correction in the DNA replication system. And he went on to stuff about cryptography and encryption of information and storage of information, storage density. And he ticked off all these design patterns that he recognized as someone working in computer science that he was seeing at work in the protein synthesis mechanism or the gene expression system. And he said, again, I get an eerie feeling someone figured this out. And then he said, except that the digital technology in the cell is being executed with an 8.0, 9.0, 10.0 efficiency beyond anything we've yet achieved. And he said, that gives me an eerie feeling, So when you take that kind of an insight and you say, well, we know things about how human engineers, how software developers and other types of engineers design things. We know the kinds of principles they employ in getting elegant design and design trade-offs. So maybe we should, if life was designed by a human or by a master programmer, maybe some of those same kinds of design patterns would be evident in life, and we should go look for them. On the other hand, if you accept that life arose by an undirected and fully naturalistic process that built life from simpler to complex, a bottom-up way, not a top-down way, with mind constructing an overall architecture and then arranging parts to conform to it. That's the way intelligent designers do things, but rather it was more of a random trial and error process. You would expect things like a vast accumulation of non-coding DNA that was not doing anything. It was just the detritus of the trial and error process. So bottom-up design would produce different types of structures than top-down being mind-first design. And therefore, the two different understandings of how life was produced or designed would generate some differing predictions about the kinds of features or systemic features or structures that we ought to find in cells. For example, Behe has made a lot of this idea of irreducible complexity. It's not something you would expect from bottom-up design, but it is something you routinely find in top-down design. And so predictions of the existence of irreducibly complex, functionally integrated multi-part systems is something you'd expect on an ID approach, but not on a bottom-up design approach of natural selection, random mutation.
That's really incredible. So somebody who's an ID scientist, sort of like the book that your friend gave you, they're going to be looking for patterns of design, but somebody who doesn't hold to that view, they're not going to be looking for that because that's just not part of their worldview.
Or part of their understanding of biological origins. They wouldn't be thinking mutation and selection can produce certain types of phenomena, but not others. So you wouldn't expect to find those other types of phenomena, irreducible complexity, computer design patterns. You wouldn't expect to find overlapping genes, for example. It's hard enough to satisfy one set of semantic constraints in the genetic code expressed as one message, but to layer 3 or 6 messages on the same set of codons and satisfy all those multiple sets of functional or semantic constraints simultaneously would far exceed the capacity of random mutation and natural selection. And therefore, it's not something that you would expect on a mutation selection account of biological origins or the origins of genetic information. So the work on overlapping genes is a good example of scientists taking the ID idea and saying, here's something that we might well expect to find if a designing intelligence was attempting to maximize the storage density of information in the cell. It's not something we would expect to find on if mutation and selection were the sole means by which biological information arose. Let's go and look, see whether we find it or not. If we find it, that would provide additional confirmation of the ID hypothesis. And guess what? It's been found. 6 overlapping reading reference frames in bacterial genomes. That's pretty exciting.
Dr. Meyer, that was some fascinating insight as to how the ID theory can lead to new research. There's actually another ID rather, from the ID 3.0 lecture that I'd like to look at. So I remember you were saying something along the lines of how intelligent design has gone through 3 different phases or 3 different forms. You said the first one sort of laid the foundation of the ideas and was critiquing evolution. The second phase, it built a very powerful affirmative case for intelligent design. And now the third is about making testable predictions, hypotheses, and doing research projects. You said that your colleague and friend, Dr. Douglas Axe, had said, "Why do we keep needing to argue? We've won the argument. It's obvious to anyone who's fair-minded. Let's now move on. We'd like to use these core concepts, functional integration, irreducible complexity, or the idea of functional information, or what we call technically specified complexity. Let's use those ideas to start making some discoveries." Later on in that lecture, you said that the Discovery Institute had, at that time, 15 different research projects going on. So Dr. Meyer, may you please share with us some of those discoveries that the Discovery Institute has been making using the ID framework?
Well, sure. I can talk about some of them. You might appreciate that some of the scientists are in positions where they have to be somewhat careful about what they reveal as to their perspective, because there's still quite a lot of pushback. And although I would say less than 10, 15 years ago, one of the exciting discoveries is precisely the discovery of, at multiple levels, functionality in the non-coding regions of the genome. A second is this discovery of overlapping genes. A third discovery that is part of an ongoing research project at Mackenzie University in Sao Paulo, Brazil, led by Marcus Eberlin, is that the proteanome, the proteins that are produced by the human genome, are quite dramatically different than the proteins produced by the chimp genome. And we're early days in that research project, but we've all heard the number that chimp and human DNA is 98 or 99% similar. We have another project that's showing that that number is itself probably inflated, that it's probably more like 95%. exempting the non-alignable DNA, which would drop that number down a little bit lower. But when we get to the proteome, the consequent of the expression of that genetic information, that number looks like it's going to be quite a bit lower, into the low to mid 80s at best, suggesting that whatever is processing the information, the post-transcriptional processing of the genetic information in the case of chimps and humans is quite different, so that we can increasingly look at the information in DNA as a kind of library of possible genetic information that can be expressed in different ways depending on how the other informational structures in the informational hierarchy are using the information according to the needs of the organism. You can't really account for the anatomical and behavioral differences between chimps and humans on the basis of a mere 1 or 2% difference in the DNA, or probably even on the basis of 5 or 6% difference in DNA sequences. So something else is at work that produces those, that is responsible, is the difference that makes a difference. And Marcus Eberlin's research suggests that may be in the post-transcriptional processing and in the informational structures in the rest of the informational hierarchy, the epigenetic and ontogenetic information that is crucial to accounting for differences in body plans and behavior and so forth. So that's another really exciting ID research project. We have an ID research project on what's called the waiting times problem. And we've had some very interesting initial papers published on that. If you analyze the mutation selection mechanism using standard population genetics modeling, it follows that we ought to be able to calculate something about how long we should have to wait for certain levels of biological innovation to occur if we know factors like the mutation rate, the generation time between parent and offspring, and so forth, and the population size. Sorry, and so we have a team of scientists, paleontologists, structural biologists, and mathematicians, population geneticists, all very high-powered people, starting to develop very sophisticated models by which they can assess how much time should be associated with a given evolutionary change, whether it's the origin of feathers or the origin of structures in aquatic mammals like whales from prior alleged terrestrial ancestors, etc. So making specific waiting times calculations with respect to very specific morphological innovations that arise in the history of life, and that's an exciting way of testing the mutation selection mechanism. And if you find that the mutation selection mechanism and other say complementary evolutionary mechanisms require waiting times in excess of what would be allowable by reasonable population genetics modeling, then it's also reasonable to infer that something other than those undirected evolutionary mechanisms played a role in the origin of those systems. So those are a few examples of some of the projects that we have going on. We have an interesting project in Israel going on that is looking at the fine-tuning, applying the concept of fine-tuning to biological systems, and showing that many systems in the cell, including things that we used to overlook, like lipids, the fatty molecules that are part of the membranes around cells, are exquisitely finely tuned to allow life to exist. We've also have a number of projects exploring the design of molecular machines, and so lots of exciting stuff going on.
Oh, that's really cool. If you don't mind me asking, I remember when we first learned about the cell back when I was in middle school, high school. One of the most interesting things to me was actually that lipid bilayer. Is that what you're actually talking about there?
Exactly, the lipid bilayer and the many glycolipid species. It turns out that not only DNA and proteins contain information, but there is intracellular signaling from sugar molecules. Sugar molecules contain information, and glycolipids contain information. And there are many different forms of these different biomolecules that have a sequence specificity to them that is crucial to function. So that's when you think about the design of life, one metaphor that my colleague Michael Denton has often used is the idea that there are wheels within wheels within wheels of complexity, indeed functional and specified complexity. And so I think we have a lot of research to do. We're not going to exhaust anytime soon our appreciation for the functionally integrated and informational complexity of living systems.
Dr. Meyer, thank you for going over all those amazing discoveries. Now, there was a discovery that you brought up in ID 3.0 that I want to touch on because it's the intersection between intelligent design theory and cancer research. You said, "We think that intelligent design has a lot to offer in cancer research, and that there are that there are some really potentially very powerful approaches to some really serious medical problems coming out of ID research." In the lecture, you spoke about how the Discovery Institute is funding the work of Dr. Tour, who is using principles derived from studying the nanomachines in nature to redesign nanomachines to solve some pretty important human problems. Dr. Meyer, may you please elaborate more on the connection between ID and cancer research? Have there been any interesting breakthroughs?
Well, I think there's something already taking place in cancer therapeutics that expresses some of the key insights that have come out of the mathematical analysis of the plausibility of Darwinian evolution and what's called this waiting times problem. It's increasingly recognized that one way to attack malignant cancer cells is not with a single drug, but with a cocktail of drugs. And there's an underlying population genetics mathematical reason for that it reflects work that was, or insights. And I'm not saying that the cancer research people are necessarily drawing directly on these insights, but the theoretical explanation of why these cancer therapeutics work is something that comes right out of Michael Behe's work in The Edge of Evolution and right out of some of the other work that we've done on the waiting times problem. And that is that the recognition that if you need multiple coordinated changes, that the waiting times required for multiple coordinated changes at a genetic level increase exponentially. And so you can very quickly get beyond the waiting times available, the time available for the entire evolutionary history of life on Earth, if what is required are sometimes 3, 4, 5, 6, 7 coordinated mutations. So what cancer researchers have been doing, or cancer therapeutics, have been whacking malignancies with a cocktail of drugs that require the malignant cells to mutate in multiple ways simultaneously, and expecting those multiple coordinated mutations to occur requires a waiting time in excess of what's available to them. And so whereas one drug may not do it because the cells can quickly mutate to avoid the effect of the drugs, a cocktail of drugs requires multiple coordinated mutations, which exceeds the time available to the organism on a probabilistic basis. So that's I think a connection between some of the work that our ID people have done on this waiting times problem and something that's already going on in cancer research. And it may also, I think, bear out in the problem. It may have some implications and consequences for the way we attack antibiotic resistant strains of bacteria, where a single drug is not going to be efficacious because the bacterium can quickly mutate and form a resistant strain. But if you hit the resistant strain with a cocktail of drugs, you may be able to put it out of business by requiring more coordinated mutations than can be reasonably expected in all of evolutionary time. So that's something. Tour's work is really interesting because what we started supporting his work because he was developing these tiny miniature machines that were humanly designed. And what he was first developing were little nano cars. You could put about 50,000 of them across the width of a human hair. And there have been different research groups that have nano car races. And this was from this, Tour developed a really original critique of origin of life research, because he showed that in living cells, there are much more sophisticated molecular machines than the ones that he and his group and other groups were making. But to build even the simple machines that he was developing required the use of very sophisticated laboratory techniques, purified reagents that you purchased off the shelf, and the execution of a very specific multi-step chemical recipe, which involved introducing the right reagents at the right time and the right concentrations with other reagents, removing unwanted byproducts and reactions, heating things to certain temperatures, quickly cooling them at the right time, et cetera, et cetera, et cetera. He gives a fantastic talk on this, which is actually quite funny, because the chemical recipe to build even a simple molecular machine has so many intricate steps. It's extraordinary. And now, from our point of view, that's clearly an expression of intelligent design, right? What he then argues is that people trying to simulate the chemical evolutionary origin of life are simulating in the best of cases, they're massively interfering in their simulation experiments. It's a problem known as investigator interference. And they're not building anything even as complicated as his nanomachines, his nanocars. And so if you need massive intelligent intervention to build even simple life-relevant chemicals, you haven't demonstrated the undirected chemical evolutionary origin of life. And so in addition to doing this interesting proof of concept nanoengineering, Tour was using lessons learned from that to provide a really powerful critique of undirected chemical evolutionary theory. Now, I should stipulate that Tour is not himself a proponent of intelligent design, though he's increasingly sympathetic to the idea. He's often careful to say he does not, as a chemist, have the tools to make the case that, for example, we do in books like my book, Signature in the Cell. But he has begun to use basic design ideas to modify those nanomachines. And he's turned some of the nanomachinery that he's made into little molecular augers or drills, which he can attach to malignant cancer cells by attaching to the drills little peptide add-ins that will bind differentially to the malignant cancer cells and not bind to the surrounding healthy tissue. And this is turning out to be a very effective way of destroying malignant cancer cells. And they've already had, he and groups that he's been working with at various cancer research centers have been able to demonstrate the efficacy of these cancer-destroying nanobots or nanodrills, first in vitro, in a petri dish, and now they're moving to in vivo experimentation as well. So this is a very exciting research program. And from our point of view, it's actually absolutely demonstrating the power of rational design over unguided evolutionary processes. And Tour himself is extremely critical of these prebiotic simulation experiments that purport to be demonstrating how undirected chemical reactions can produce life-relevant chemicals and structures, when in fact what they're demonstrating, in my view, and I think Tour's as well, is that the investigator has done all the important work by applying his own intelligence.
That's really incredible. So it's almost like ID-based principles have now become applicable in life-saving situations.
I think so, absolutely, yes.
Well, Dr. Meyer, in your book, Signature in the Cell, while you're not exactly making the case that ID is life-saving, you are making the case These are, you said, its ID is the best, most causally adequate explanation for the origin of the specified digitally encoded information in DNA, and intelligent design best explains the DNA enigma. So, Dr. Meyer, there are some evolutionary scientists who would take objection to that assessment. The University of California, Berkeley, it states, living things, even ancient organisms like bacteria, are enormously complex. However, all this complexity did not leap fully formed from the primordial soup. Instead, life almost certainly originated in a series of small steps, each building upon the complexity that evolved previously. The journal NCBI states the first step in the emergence of DNA has been most likely the formation of uDNA, DNA containing uracil, since ribonucleotide reductases produce DUTP or DUDP from UTP or UDP, and not DTTP from TTP. The latter does not exist in the cell. Some modern viruses indeed have a uDNA genome, possibly reflecting this first transition step between the RNA and DNA worlds. So, Dr. Meyer, is that a plausible evolutionary explanation for the origin of DNA? And if not, how can the ID framework account for these points?
It doesn't explain the most important thing that needs explaining, which is the origin of the sequence specificity of those bases. Whether you make the U to D substitution or U to T substitution or not, it doesn't. You still have to sequence the bases. There are four. This was the great insight of Francis Crick and with his sequence hypothesis, was the idea that the bases along the spine of the DNA are functioning like alphabetic characters in a written text or like zeros and ones in a section of machine code. That is to say, it's not their physical properties or their their molecular weights or their shapes that give them their function, but rather their specific arrangement in accord with an independent code or symbol convention, now known as the genetic code. Whether the four letters in question are A, T, G, and C, or A, U, G, and C matters not. They have to be arranged in very particular ways to perform biological functions. So simply positing that there was an earlier form of DNA that used uracil instead of thymine, as RNA does, doesn't solve the problem of the origin of information, nor does the RNA world hypothesis do so, which is something I explain in the new book, Return of the God hypothesis. Because RNA world research has been posited as a counter-argument to my earlier argument for intelligent design in Signature in the Cell. I have a whole chapter on critiquing the RNA world hypothesis, and I would recommend it to people. Everything I wrote there in chapter 14 of Signature in the Cell is still apt. But some have said, well, there's been these new researchers that have shown that you can get RNA to copy itself. I show in the new book that those alleged RNA self-replicating, those alleged self-replicating RNA molecules do nothing of the kind. What they're actually doing is fusing two pre-sequenced halves of another RNA molecule together. They're joining, making one linkage. They're not copying a whole molecule, which would require what's called polymerization, not just ligation or fusing. And secondly, the pre-made halves have to be sequenced by the investigator, as does the original ribozyme. And so the bottom line is that the best we've been able to do, making our own synthetic molecules of RNA, our own in ribozyme experiments, that is RNA molecules that allegedly can create the first self-replicating system. The best we've been able to do in the lab is make RNA molecules that can copy about 10% of themselves. And only then, if the experimenter specifically sequences the information carrying bases, the A's, U's, G's, and C's on the RNA, or the A, C, G's, and T's on the DNA. So positing an earlier information-bearing molecule doesn't solve the problem of the origin of life unless you can explain the origin of the information on the molecule. And that applies to DNA and alleged earlier versions of DNA and RNA as well. All of those molecules are only functional if the bases are sequenced properly. And as Christian de Duve, the great Nobel laureate, in biochemistry and molecular biology, who was a leading origin of life researcher, put it that no one, with respect to the RNA world, he said, no one has yet figured out how to sequence the molecules, how to hitch them together in the correct sequence. That's an unsolved problem. So what you just cited does not address the fundamental problem of the origin of information.
Dr. Meyer, thank you for going over the evolutionary explanation for the origin of DNA. And while we're on the subject of evolutionary explanations, the takeaway I got from your book, Darwin's Doubt, was that intelligent design is the best explanation for the origin and the physical traits of life. In your chapter, The Possibility of Intelligent Design, you wrote, "Clearly, standard evolutionary theory has reached an impasse. Neither Neo-Darwinism nor a host of more recent proposals have succeeded in explaining the origin of the novel animal forms that arose in the Cambrian period. Yet all these evolutionary theories have two things in common. They rely on strictly material processes, and they also have failed to identify a cause capable of generating the information necessary to produce new forms of life. This raises a question. Is it possible that intelligent design, the purposeful action of a conscious and rational agent, might have played a role in the Cambrian explosion?" So critics of intelligent design, like those at the University of California, Berkeley, they'd say that the testable claims of intelligent design deal more with discrediting evolution than with the mechanism of intelligent design. So Dr. Meyer, how would you respond to that criticism of how did the designer design?
Well, the critique betrays a confusion. The theory of intelligent design is not positing a mechanism. Mechanisms are material-based causes, and we're positing the action of a mind. So we are positing an alternative cause. We have ways of testing whether our hypothesis of the action of such a cause in the history of life is in fact the best explanation for certain phenomena. But we will never propose a mechanism of intelligent design because mechanisms are associated with materialistic causes, and we're positing an alternative to materialistic causes. So to fault us for not providing such a type of explanation is to misunderstand the nature of the proposal itself, and to be wedded to what it subtly betrays is this criticism subtly betrays the understanding that science must limit itself to strictly materialistic explanations for everything. And we contest that. That's part of what is at issue. Because when we're talking about the explanation of events in the history of life, when we're talking about questions of causal origin, it might be the case that purely undirected material processes have produced all that we see, including the first life, the fine-tuning of the universe, the explosion of new animal forms in the Cambrian period, or the origin of human language. But it might also be the case that a pre-existing mind played a role in the origin of some of those events or systems. And a good science, an intellectually open science, is open to all such possibilities. And to preclude them by definition, to say that, well, science must limit itself to strictly materialistic explanations that therefore provide mechanisms, is, I think, intellectually limiting. A good science should be open to all possible explanations and allow the evidence to dictate the conclusion. The conclusion should not be dictated by a prior a priori commitment to a certain kind of explanation to the exclusion of others. And when intelligent design is faulted for not providing a mechanism, that is just another way of smuggling in that same assumption that all explanations for all phenomena must be tendered in strictly materialistic terms. And just to give a quick example as to why such a limiting assumption is in fact limiting, and in a way that's anti-intellectual, that might keep us from getting to the truth, consider a hapless soul who walks into the British Museum and observes the Rosetta Stone, and is then asked, well, what caused these interesting inscriptions, these three different styles of inscriptions on the rock? Well, someone committed to the principle of methodological naturalism will have to provide a materialistic explanation. And so, therefore, the person looks at the inscriptions and says, well, I guess it must have been something like wind and erosion, or maybe chemicals etching the rock. When in fact, he or she knows, based on his uniform or her uniform and repeated experience, that information of the kind inscribed on that stone always arises from an intelligent source. So methodological naturalism applied consistently and across the board could prevent us from coming to the right answer, an answer that is supported by the evidence, but not permitted by the assumption of methodological naturalism. So we're challenging that assumption because we favor an open philosophy of science that allows us to infer the best explanation, not just the best explanation among an artificially limited set of options.
That actually, what you were saying, it reminded me of what Paul Nelson said. He said something along the lines of like, when you walk into a crime scene and then you see a knife in somebody's back, you're not going to assume that like gravity or the laws of nature was what caused this person to have a knife in their back. You're going to assume that an intelligent agent, somebody with a motive purpose, put that there. And he said that if you're just going to be bound to methodological naturalism, that forensic evidence isn't accessible to you because you're ruling out the obvious answer.
Exactly. No, that's a very good example. Yeah, we want to open up the inquiry. We acknowledge that there are certain kinds of questions in science for which positing intelligent agency or intelligent design would be inappropriate. And not because of the rule of methodological naturalism, but simply because of the framing of the question itself. If we ask, how does a given protein bind to a particular part of the cytoskeleton? We're not going to say intelligent design, or it was intelligently designed by God. We're going to say, well, it binds when this part of the molecule attaches to this part, because you're asking about how one part of nature affects another. The frame of the question requires a naturalistic answer. But not all questions in science are framed in that way. Some are about ultimate causal origins or causal origins, in which case we need to be open to all different possible types of causes.
So, Dr. Meyer, I'm grateful that you showed that intelligent design, it's not just some critique of the evolutionary theory, it's a fully fledged theory on its own.
We're offering positive evidence for intelligent design based on our uniform and repeated experience. We know of only one cause that produces what we call specified complexity or functional information, and that cause is a mind, intelligence. Therefore, when we find specified complexity, even in living systems, not just on the Rosetta Stone or in a cave painting, but when we find that specified complexity within living systems, we have a strong grounds for inferring the activity of designing intelligence in the history and origin of life. So we're basing our inference to design based on not our ignorance, but our knowledge of cause and effect, and our knowledge of the features that are present and have been discovered in living systems.
Thank you so much for that insight to the actual purpose and the clarification to the role that idea is playing. In these last few questions, we took a look at your other books, but now let's take a look at the new one, The Return of the God Hypothesis. Dr. Meyer, the opening chapter of your book, it had me hooked from the title, The Judeo-Christian Origins of Modern Science. Under the heading, A Different Understanding, you wrote, historians note that belief in God and Christianity specifically played a decisive role in the rise of modern science during the 16th and 17th centuries. In the next chapter, Three Metaphors and the Making of the Scientific World Picture, you wrote, presuppositions derived from a Judeo-Christian worldview help to inspire and shape the foundation of modern science. So, Dr. Meyer, it sounds like you were saying that Christianity was instrumental in bringing about modern science. So has that role stayed the same? What role does Christianity play in the flourishing of science?
Well, I would say that a general theistic perspective is a much more natural soil in which for science to flourish, because theism, Christianity being one form of theism, and it was the important form of theism that was at work in the period of the scientific revolution, The theism assumes, first of all, the intelligibility of nature. It presupposes the existence of a rational creator who therefore would have built rationality and order into nature. Many of the biblical texts speak of God as a God of order and speak of the order that he imposed upon nature. That's a third presupposition that was crucial to the rise of modern science, and that was the idea of the contingency of nature upon the will of a divine creator. So yes, nature is ordered, but the early scientists recognized that nature could have been ordered in many different ways. And so, for example, Sir Isaac Newton discovered that gravity functions according to an inverse square law, where the force is inversely proportional to the square of the distance between the two bodies. But it might have been inversely proportional to the cube of the distance between the two bodies, or it might have had some other mathematical relationship governing the gravitational attraction. To find that out, one could not sit and simply make a series of deductions from some logically certain set of axioms or first principles. Scientists had to go and look and to see. They had to investigate. So the understanding that nature was contingent, yes, there was an order there, but unlike the Greeks who thought that the order in nature was sort of intrinsic to it in a logically self-evident way that would allow scientists or philosophers simply to kind of from their armchairs deduce what nature must be, the early founders of modern science understood that nature had an order that had to be discovered by investigation, by observation. So Robert Boyle famously said that the job of the natural philosopher is not to ask what God must have done, but to instead go and look and to see what he in fact did do. And so this shift from Greek thinking, what was called necessarian theology or philosophy, nature must function in a certain way that seems logically self-evident to us, to a more Judeo-Christian mode of thinking that credited nature as being a creation of a divine mind and viewed nature as being contingent on the will of that creator, led to a more empirical approach to science. I think, as we've already talked about, the concept of design is very fruitful for science. We know something about how designing agents do things. So we can look to see if similar, and we know what kinds of structures designing agents produce. So we can go and look to see if those kinds of structures are present in nature as well. Anyway, I think just as this Judeo-Christian theistic framework was very fruitful for science in getting it going in the period of the scientific revolution, I think the return of the God hypothesis that's coming because of these big discoveries I talked about in the book from about biological and cosmological origins, I think those new discoveries and the restoration of a theistic perspective will be very fruitful for science going forward as well.
Wow, so it's almost like Christianity and science, they sort of fit together like lock and key.
Beautifully so. There's a wonderful book by the Baylor and former University of Washington historian of science, Rodney Stark, called For the Glory of God, published with Princeton University Press, about the theological inspiration for doing science, for investigating the natural world in the first place. The Principia, after all, was Newton's attempt to expose the mathematical principles that underlay the functioning of the physical world. And in so doing, he believed he was bringing glory to the mind of God that had conceived of those mathematical principles and imposed them on nature. He even wrote a theological epilogue to his great work called the General Scholium, in which he argued that, first of all, we see evidence of design in nature, in the exquisite balance of the planetary bodies and the comets and the sun in our solar system, which he said could only proceed from the counsel and dominion of an intelligent and powerful being. And as to the laws of nature, he spoke of them as an expression of God's constant supervenience or governance over nature, and said, in God, all things are held together. So he had a profoundly theistic philosophy of nature or theology of nature, and he also made arguments that we could categorize as natural theological arguments, nature pointing to God. So science was a profoundly theological project at its inception. And there's absolutely no reason that theists working in science today can't continue to make great contributions. And in fact, I think their theistic worldview is an aid in making such contributions, not something that will, not a detriment to the scientific practice.
That was an amazing quote right there. So, science is theology's project. You said something like that. That was incredible.
Our friend John Lennox, the great mathematician and philosopher of science in Oxford, has said that I'm not ashamed to be a scientist and a Christian. Christianity gave me my discipline, he likes to say. And so I think that's true. And I think that Judeo-Christianity contributed to that. We see the Hebrew Bible was a huge influence on the concept of the laws of nature. There's a historian of science named Edward Zilsel who points out that the whole concept of the laws of nature is a juridical metaphor of theological origin. And he goes back to show how the early scientists got the concept of God constraining nature so that it manifested orderly patterns from passages in the book of Job and in some of the Proverbs. So I think all three of the great strains of Western Judeo-Christian religion have played a role. Certainly the Hebrew Bible, certainly late Catholic medieval scholarship was critical to this. Figures like Grosseteste and Aquinas, and the Protestant reformers as well, in their emphasis on the fallenness of man as recorded in the book of Genesis, and that fallenness meant that we couldn't completely trust our minds. Yes, our minds were made in God's image, but we were prone to flights of fancy, to jumping to conclusions, to biases, and therefore we had to test our ideas against nature itself. That also led to a more empirical approach to science. And the reformers, like many of the theologians in the late medieval period of many of the Catholic theologians in the late medieval period, also were recovering this doctrine of creation and extricating Christianity from a more Aristotelian view of reality that I think undergirded their sense that nature was contingent on the will of a creator, and therefore required our empirical investigation.
That actually reminds me of something that you said in the Return of the God Hypothesis. There was a chapter called The God Hypothesis and the Design of Life. You had this interesting picture. It was called Multiple Competing Metaphysical Hypotheses, where you had materialism versus pantheism versus panspermism versus deism versus theism. So I'm wondering, do those other worldviews besides theism tend towards the flourishing of science? And if not, why not?
Well, I think the most important worldview in that mix is obviously scientific materialism. And many scientific materialists or scientific naturalists have claimed that a naturalistic worldview is a necessary condition for doing science, because we've got to get rid of reference to the activity of gods and so forth. But what I show in one of the later chapters of the book is that materialism has led to the need to account for things like fine-tuning and the origin of the universe, and even the complexity of life, by positing concepts like the multiverse, the idea of an infinite number of other universes. And that once one concedes the possibility of an infinite number of universes, all these different forms of infinite universe cosmology are inherently antithetical to the trust in the reliability of the human mind. If there's an infinite number of universes, and we might be in any one of them, it follows that anything could happen at any time for any reason within our universe, because our universe could be governed by completely idiosyncratic laws of nature, where regular patterns could be suspended at any moment for irregular types of relationships between causal antecedents and consequence. Anything could happen for any reason at any time, which makes it impossible to make scientific predictions. It undermines our confidence in our scientific explanations of events that we have witnessed in the past. And furthermore, it gives rise to the possibility of what are called Boltzmann brains, centers of consciousness that have arisen with false memories as the result of random quantum fluctuations, and that we ourselves might be such entities. And as fanciful and bizarre as that possibility sounds, it's been a problem that's been almost impossible to solve by materialistically minded physicists and philosophers of physics. And I go into this in some detail. So it's actually materialism that ends up destroying our confidence in the reliability of the mind. Even the evolutionary account of our higher cognitive capabilities is really, really sketchy and contradictory to the reliability of the mind. It undermines our confidence in the reliability of the mind. And I just discuss this a little bit in chapter 21, the concluding chapter of the book. So I think a worldview that gives rise to confidence in the reliability of the human mind, in the intelligibility of nature, in the order of nature, is the worldview that is going to best undergird the scientific enterprise. There's a famous maxim from St. Augustine, credo ut intelligam, or credus, there's another variant on it, I won't try it. But anyway, the idea, we must believe in order to know. What must we believe in order to know? We need to believe in something that credits the reliability of the human mind and the intelligibility of nature. And theism has been by far the most effective system of thought for sponsoring scientific investigation, precisely because it affirms those two key propositions that one must believe in order to do science.
That sort of reminds me, there's this interesting quote from Sean Doyle. He said something along the lines of, our ability to reason is powerful evidence against materialism.
I agree with that. One of the arguments that first moved me to a theistic position philosophically was the argument from epistemological necessity. I think theism provides the best explanation for how our minds could be reliable, and therefore for our ability to reason at all.
Well, Dr. Meyer, we've actually now arrived at our final question. So I love the title of the new book. It's The Return of the God Hypothesis. It does, however, beg this interesting question: who is the God that is returning? Dr. Meyer, the Apostle Paul said, "For since by man came death, by man came also the resurrection of the dead. For as in Adam all die, even so in Christ shall all be made alive." So, Dr. Meyer, is the God of the God hypothesis the same God who made Adam, the same God who redeemed Adam's fall? How can we be saved?
I, of course, believe that. I've made no a secret of the fact that I am a believing Christian. The book makes an argument for theism, basic theism, a God who transcends matter, space, time, and energy, who is intelligent, and who acted to design the universe as a whole, and who has acted within the creation that he otherwise sustains and upholds on an ongoing basis. I affirm what both the psalmist writes, that the heavens declare the glory of God, and what St. Paul writes in his epistle, that from the things that are made, the unseen qualities of the Creator are clearly manifest, his eternal power and divine nature, sometimes translated wisdom. The psalmist multiple times says, "In wisdom thou hast created all things." So I think we see the evidence of the wisdom and the power of God in nature. I think we see evidence of a God who is transcendent and who is also active in the creation, so not a deistic creator. There are non-religious theists who believe in such a God. And there are other religious traditions who affirm that concept of a theistic rather than a deistic creator. And so the arguments from nature, I think, do not help us settle the differences between different forms of theism. I think even in the Christian tradition, St. Paul not only affirms the validity of natural theology, but he also places limits on it. He doesn't say, well, from nature, you can't tell from the evidence of the Big Bang or from the genetic code, you can't discern the Christian gospel, for example. That to decide whether that's true, whether the Christian view of God or the Jewish view or the Muslim view or various non-religious views are correct, you need other forms of revelation. And that's why theologians make a difference between a general revelation and special revelation. And that's why, by the way, many of my Jewish colleagues are as happy with the argument I'm making in this book as many of my Christian friends. So this is the argument of this book is neutral with respect to those questions that would need to be adjudicated to decide between different forms of theism. But it does bring us quite a long ways from the materialist zeitgeist and default way of thinking that has governed our culture, I think, for quite a long time now, since the late 19th century. And it even brings us further than I took us in the first two books, making a case for a designing intelligence of some kind. I think we definitely see evidence of nature for a designing agent who has the attributes that Jews and Christians have long associated with God: transcendence, intelligence, and therefore personhood, and a willingness to be active in the creation, not an absentee landlord of deism, and not a space alien. And we'll be hearing a lot about space aliens in the next couple of weeks, I think, with this report coming out about the UAPs from the Navy. If such things exist, and I don't have any considered opinion to offer on that, they certainly still do not explain the origin of the universe or its fine-tuning or even the origin of life. I think for that we need a transcendent intelligence to account for what we see in nature.
Amen. And so, if you don't mind, I'm going to ask one more question. It's kind of off the script, but I remember you mentioned that there's got the general revelation, so that's what we can see in science, and you have the special revelation. And so when you're looking at, our lives as humans, this is kind of a personal question. So you're a Christian. How do you relate to the designer, God?
I certainly have my relationship with God has been enhanced by my awareness of his handiwork. And I often go to a place in the San Juan Islands here in the United States. And when I'm there, the sky is a lot darker at night with less ambient light. I'm more aware of the movement of the planets from night to night. And I begin to reflect on all of those amazing design parameters that are necessary for our Earth to be in a stable orbit at just the right distance from the sun, at just the right axial tilt, with a large gas giant out further in the solar system, sweeping up the asteroids and meteorites, protecting us from those collisions. And I begin to reflect on the many different parameters that had to be just right to allow this beautiful planet to keep spinning like a top in free space 93 million miles away from the sun. And I see the sunset every night and the sunrise the next morning. And so my scientific background and my awareness of these many propitious, finely tuned parameters gives me really a sense of awe that I may not have had without the benefit of that scientific background and the propensity I have to think about some of these things more abstractly. But I wouldn't say that that's the primary way I relate to God. I've had a religious conversion experience. I have a definite sense of the presence of the Holy Spirit in my life. And as I read the Bible, the scripture, I find that God reveals himself in a more specific and personal way that enables me to get an even better sense of who he is and what he expects of me. And with the presence of the Holy Spirit, I also sense even definite guidance for day-to-day decisions. So I think there's a general awareness of the reality of God that we can derive from nature. But I think he does call us into a more personal relationship if we're open to that. And I think the Bible and the Holy Spirit have been very important ways by which he's revealed himself to me in that more personal way.
Dr. Meyer, thank you very much for your time. It was an absolute joy. And to our listeners, thank you for taking the time to learn with us on current topics in science, where scientific discoveries are examined in light of the origins issue. You can find Dr. Meyer's biographical information, his scientific papers, his books, Signature in the Cell, Darwin's Doubt, and Return of the God Hypothesis, links to his personal YouTube channel and website, along with links to the Discovery Institute website and YouTube channel in the description. Please share and subscribe to the Current Topics in Science podcast. It's available on iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Thanks again for listening, and remember, the truth saves.